systems of linear equations, and well, linear equation y equals to mx plus c, where m is your gradient and c is your y-intercept. So now there are three systems of linear equations: unique solution, no solution, infinite, many solution. So unique solution is more of the two lines have one point of intersection, so that happens unique solution. And that only happens when m1 does not equals to m2. So two equations when the first gradient is not the same as the second gradient, the second equation gradient. And you have no solution, which is parallel. So the two lines are, they won't touch. So two lines that actually face the same direction, and they face in the same direction, but they won't touch. C1 does not equal to C2, but M1 equals to M2. So that's also a parallel one. So infinitely many solutions. So that is a scenario whereby the two lines, so line 1 is on top of line 2. So that is infinitely many solution. So M1 equals to M2, C1 equals to C2. So let's have a look at an example whereby we want to find out the no solution and infinitely many solution. So let's take this example. So y mx plus 2y equals to 8, 4x minus 2 minus m, y 2m. So I want to find the value of m. So that's the first thing we have to do. So find So once we do that, so the next thing we have to do is to find when it's no solution. Find the value of m when no solution. No solution, also known as parallel. So the two lines won't touch. So m1 equals to m2. And 2, infinitely many solution. All right, so first we need to put the equation, the first equation. So this is your first equation, and this is your second equation. So we want to put these equations in a format of y equals to mx plus c. So this is m1, c1. So y2, m2, x, c2. So we want to rearrange this. So I want to make y the subject. So 2y, 8 minus the first equation. And we divide both sides by 2. So this is y1, y2. We do the same thing for the second equation as well too. So we rearrange. So 2m minus 4x. So we need to divide this whole lot. So that's here the coefficient of the y. So we need to divide it. So that's going to be the negative also comes with it. So it's going to be 2 minus m. So that becomes positive because of the negative there. So now we have, so my m2 will be, this whole lot is my m2. And this is my c2. So now we need to equate the two. So the next thing we have to do is equate the two. So now we know that c1 equals to c2. So we want to equate those two. And also we want to equate m1 equals to m2. Alright, so that is our m values for the first equation. So and 4, 2 minus m. So that's going to be, I've equated the m's. So I want to solve for m. So cross multiply, so that gives me an minus. So that's going to be minus 2m plus m squared. So cross multiply this all to the other side. It's going to be 2 times 4, 8. So rearrange the whole equation, and that gives me an equation of which we need to find out two numbers. When you multiply those two numbers, gives us negative 8, and when you add, gives us negative 2. So that's going to be m minus 4, m plus 2. So m is 2 or 4, 4 or negative 2. Can also do the same thing with the c. So our c1 was 4 equals to negative 2. So it's going to give me the same answer as well. So that's going to be 8 minus 4m equals to negative 2. So that gives me one value. So that gives me 2m. So m must be 4. All right, now we want to find out what is the, so that's going to be the C1. This is C1 and C2. So I want to find out when it's no solution and infinitely many solution. All right, now when m equals 2 and negative 2, so if I substitute negative 2 into this equation, so that's going to be negative 2 there, 2, 4, 2, negative. So that's going to give me 1, and that's going to give me 1 again. So that is, so the m's are the same. So let's find out if m1 equals to m2. All right, let's find out if c equals to c2. So this is, and the c value is actually 4 for c1. So c2 is, so when m equals to negative 2, we want to find out what is my m1 and what's my m1 and m2, c1 and c2. So now, so that's going to be 4 equals to negative 2 into bracket negative 2 there. I'm just going to substitute the value of this m into that value of m. So that gives me 4. So that's 1. So 1 does not equal to 4. So therefore, it's no solution when m equals to, no solution when m equals to negative 2. So I want to find out when m equals to 4 now. So we've got two values of m. So I want to find out when it is infinitely many solution and no solution. So when m equals to 4, I want to find out left hand side should equal to the right hand side. So it's going to be negative 4 over 2, 4. So that's going to give me negative 2. Negative 2 equals to negative 2. How about C? So M1 equals to M2. And it's infinitely many solution when M1 equals to M2 and C1 equals to C2. So let's find out if C1 equals to C2. So C1 was 4. And C2 was negative 2M over 2 minus M. So I want to find out, I want to substitute M in there. It's the value of M, which is 4 this time. So that's negative 2. Negative 8 over negative 2 is positive 4. So 4. So C1 equals to C2. So therefore, infinitely many solution many solutions when m equals to negative 4. So when m equals to 4, when m equals to 4 is infinitely many solution. On m equals to negative 2, it was no solution. And that's it. That's how you do it. And if you end up getting this type of question, so you should be able to do it. All right then.